In our last video, we talked about recursive equations for sequences. Those were equations that used previous terms to get the next term. Remember in this, we multiplied the previous term by 2 and added 1. We multiplied this term by 2 and added 1. And so on, and so on, and so on. What if I asked you what the 20th term of the sequence would be? Well, you'd have to say, I would need to know what the 19th term in the sequence would be to figure that out. And to figure out the 19th, you need to know the 18th. And to figure out the 18th, you need to know the 17th, and so on, and so on, and so on. That can get kind of labor intensive. So we can often write what's called an explicit equation for sequences. An explicit equation for a sequence allows us to go from n, which is just the number of the term, directly to the value of that term, which is what we call a sub n. Let me show you an example. Here's an example of an explicit equation for a sequence. Okay, so this gives me a rule that will generate each term. So for example, a sub 1, my first term, is going to be, well, what do you think I substitute in for n? Yeah, I'm going to substitute in a 1 for n. So this rule, this explicit equation, tells me that a sub 1 is 4. A sub 2, well, now n is 2, so I'm going to replace that n with 2. That gives me a 7 for my second term. A sub 3, well, I'm going to replace my n with 3. That gives me 3 times 3, 9, a 10 for my next term, and so on, and so on, and so on. So my sequence is 4, 7, 10. Wait, I'm seeing a pattern. What do you think is going to come next? Sure, 13, 16. Oh my gosh, this is an arithmetic sequence. My first term is 4, and I'm adding 3 each time. This is an explicit equation that generated this arithmetic sequence. Let's look at another example. Here I'm given the rule that a sub n is n squared. So let's generate some terms in this sequence. If I plug in a 1, I'm going to replace the n with 1, and I get a 1. What's my second term going to be? Well, I'm going to replace my n with 2, and I get a 4. What's my third term going to be? Well, I'm going to replace my n with 3, and I think you see where we're going here. And I could go on and on and on. But here is my sequence that this explicit equation generated. 1, 4, 9, 16. What's going to come next? Sure, 25. These are our perfect squares. Is this geometric? No, it's not, because I'm not multiplying by the same number each time. Is it arithmetic? No, it's not arithmetic, because I'm not adding by the same thing. This is another sequence, but it definitely has a pattern, and this explicit equation generated that sequence. So basically, the bottom line is when you are given an explicit equation, all you need to do to generate each term is just to replace the n with the number of the term, follow the rule, and get your numbers. Not too bad. So we've talked about recursive equations for sequences and explicit equations for sequences. Here's the same sequence, 4, 8, 12, blah, 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 4, 8, 12. This would be one way I could express the sequence using a recursive equation. You can pause the video and make sure that works. Here's an explicit way to describe the sequence. So sometimes there are going to be sequences that lend themselves more easily to recursive definitions, and there's some where explicit equations are easier. One advantage that explicit equations have is I can find any term very easily. Remember at the beginning of the video I asked if I wanted to find the 20th term, well, if I only had a recursive equation, I would need the 19th term, right? But with an explicit equation, I could find the 20th term with ease. Well, the 20th term is just a sub 20. I just replace the n with 20. So I know that if I kept on going, blah, 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 the 20th term would be 80. That would be the 20th term. Whereas to find the 20th term here, I'd have to say, okay, well, let's see, I'm adding 4, so that would be 16, and then 20, and then 24, and then 28, and then 32, and blah, blah, blah. I'd get there eventually, but the explicit equation allows us to find specific terms very easily. So that's one advantage explicit equations have. These, of course, are both arithmetic sequences. We talked about how arithmetic are connected to linear functions. You're adding 4, adding 4, adding 4. Just for fun, where do you see that constant change of 4? Yeah. If I were to graph this, 4 would be the slope of a line generated by these points. Ah, math is just so cool, isn't it? All right. Hope you enjoyed this.